All right. So, guys. All right, altitude. So first thing I want you to draw for altitude in this box is I want you to draw a triangle. That looks cute. Now look, I drew one. Look at how big I drew it as well. Because then I'm also going to have you draw a second triangle in just a minute. All right. But if I was to draw in the altitude for this triangle, this one was a cute triangle. And the altitude would be that green line I just drew in. It is the line from the vertex perpendicular to the opposite side. If I was to draw an obtuse triangle, something that looks like that, then I could say that my altitude is actually on the outside of the triangle. So again, your altitude could fall inside a triangle, it could fall outside the triangle. Now, what we need to know is that the altitude is the segment from the vertex perpendicular to the opposite side. So segment from vertex perpendicular to opposite side. Now, the median. I mentioned median last week. Anybody remember what it was?
The middle.
All right, it is a type of middle. Well, there's lots of middles in the triangle, though. Middle how? It went from the vertex to what?
Because I can't read the number one.
So what on the base? All right, I'll read this again. For the altitude, again, segment from vertex perpendicular to opposite side. Median. If you draw a triangle, thank you. Oh, sorry. Really? I know. Sneeze, please. All right. So we have the median goes from the vertex to the opposite midpoint. So what I want you to label on here, on the bottom here, I'm going to try to draw on approximately where I think the midpoint would be. So I can go ahead and label these two pieces as being congruent. And the median would connect the vertex to that midpoint. So again, segment from vertex to opposite midpoint. Now, hopefully you guys are more familiar with the bottom two, perpendicular bisector and angle bisector. We had these in the beginning of the year. So a perpendicular bisector, I don't really need to write a definition for because it's basically what it says it is. It's perpendicular and it's bisecting. What is it bisecting? It's bisecting a segment, so one of the sides of the triangle. So I'm going to have it bisect the bottom piece. So just like I did on the last one, I'm going to draw where I think the midpoint might be. So I can label these two as being congruent, so I can clearly tell that's my midpoint. And then the perpendicular bisector would be a perpendicular line going through that point. For an angle bisector, again, drawing another triangle. Now I draw a line that is going to bisect one of the angles. I'm going to do the top angle. And I think it roughly is about there. Yes, you may. Pass this up there. So those two are roughly congruent. Now, notice, is the angle bisector going to the midpoint of the opposite side? No. Again, that's not a property. I do not want to see you guys say anything like that on like the next test, because it's a very common mistake that people always get wrong. Again, angle bisector is just bisecting the angle. All right, so again, has nothing to do with the opposite side. Now, points of concurrency. All right, first we have to know what a point of concurrency is. Does anybody by any chance know what a point of concurrency is? Okay, so a point of concurrency is where 3 or more lines meet or intersect. So on this one, a triangle is very special because if you draw in the altitude, the median, the perpendicular bisectors, or the angle bisectors, and draw in all 3 of any of those, for each set, they would meet at one point. So all the altitudes meet at one point inside the triangle or around the triangle. For a median, if you drew in all 3 medians, they'd all intersect at one point. All 3 perpendicular bisectors intersect at exactly one point. All angle bisectors intersect at exactly one point. Now, it's not going to be the same point. So, when we're looking at these points of concurrency, sometimes you might refer to them as the center of the triangle. But center of the triangle is a very vague term because what do you consider the center? All of the things that we are going to talk about today could be considered a center point for a triangle. So, and you just have to know which ones create them, and then we'll talk about the special properties here in a minute as well. First off, the names. The first one, where all the altitudes meet, it's called the orthocenter. Yep. So where the altitudes meet is the orthocenter. Where the medians meet, it's called the centroid. Where all the perpendicular bisectors meet, it's called the circumcenter. And where all the angle bisectors meet, it's called the incenter. Now, we're going to draw diagrams for each of these, all right? They do not need to be perfect, all right? Based on what we have here so far, this, again, is the farthest that you need to know for the quiz tomorrow. Again, you need to know stuff from section 13 that we reviewed over yesterday, and then this first part, but that's as far as you need to take it, all right? For the test next week, you'll have to know the rest of this stuff, all right? So, for each one of these, I'm going to draw a diagram, all right? On the first diagram, we're going to draw a triangle. I would recommend drawing an acute triangle. Okay. So I have an acute triangle. In this acute triangle, I'm going to draw in all the altitudes. So to make this easy, I'm going to try to draw in a line first perpendicular to the one that's on the bottom right now. And then to help draw the other ones, I'm going to actually rotate my paper because it's easiest to draw perpendicular lines when one of the lines is horizontal and one of them is vertical. So I'm rotating my paper so that looks horizontal. So now I can draw in a vertical line from the next one. And then if I rotate my paper again, so that this side is now horizontal, I should be able to draw another line. When I draw on this line, all 3, if accurately done, should go through the same point. And that's a point of concurrency. That would be where our orthocenter is. So that's our orthocenter right there. Now, the orthocenter can be in different places. All right, I told you guys I recommended drawing an acute triangle so it's easy to see. All right, but if you look on the board over here, I drew 2 triangles off to the side earlier. You see the 2 that are like right there, right? Those are 2 examples of an orthocenter that's not in an acute triangle, we have the top figure there is an obtuse triangle, and you'll notice if I extended each one of the altitudes, they'd end up intersecting far outside the triangle. The other one is of a right triangle, and you'll see that on this diagram it was green, and then I had to highlight some parts in blue, because if you have a right triangle, the sides, the legs of the right triangle end up being the altitudes. So you have those two altitudes, and then you also have the other altitude that's coming from the hypotenuse, and they all intersect on the triangle at the right angle. So again, it's easiest to see the orthocenter if we're dealing with an acute triangle. That's why I asked you to try to draw an acute triangle. But you can have it in any type of triangle. It's just not always going to be inside the triangle. So what I'd like you to do for the special properties over here, first off, there are no special properties for the orthocenter. However, the thing that you should know is the location is dependent on the type of triangle. So, if it is a right triangle, it's going to be, whoops, I wrote it right. Sorry, I thought I was writing something wrong. It's going to be on the triangle at the right angle. Sorry for the lines going through the paper. I didn't notice before I ran my copies that there was something on the scanner. For an acute triangle, it's going to be inside the triangle. Well, what did I just do? I just put triangle twice. Let's try that again. Inside the triangle. And then for an obtuse triangle, it's going to be outside the triangle. Okay, the next one is the centroid. The centroid probably has the most properties that we're going to have to know. So first, I would draw a triangle. It doesn't really matter what type of triangle. I would say either acute or right would be fine. I mean, obtuse would work as well, but let's draw a triangle. And then we're going to draw in all three medians. Now, what we're going to do in order to do this, I'd start with two medians first. So pick a midpoint on one side where you think the midpoint might be. Again, it doesn't have to be perfect. On the other side, pick, again, where you think the midpoint might be. And then draw in those two lines. So from one vertex to the opposite midpoint. So that those are congruent. From another vertex to its opposite midpoint. So that those two pieces are congruent. And then finally, for the last one, we still want to draw in the last one, but in order to make our diagram look good for our notes, instead of drawing the midpoint first, go from the vertex through that same intersection, and you should end up at the midpoint. Does that make sense? Mm-hmm. So, to make it look good for our notes, we're going to draw a straight line from the vertex through the centroid, and it should end up at the other midpoint. And then you can label that one as being congruent as well. Now, the centroid has the most properties, like I was saying. First off, it's known as the center of gravity for the triangle. Center of gravity for a triangle. The other thing that's really important is the centroid is 2/3 the distance from the vertex to the midpoint along a median. So the centroid is 2/3 the distance from the vertex to the opposite midpoint along the median, along a median. All right. So the first one. Now my last class ruined my triangle here. So let me. I think this one was the same size. Yeah. So let me mark this real quick so that I can show you what I mean. All right, so just as an example, so I have a triangle. I've marked all the midpoints on my triangle. If I then draw in, and I just did this by measuring, so it's not going to be perfectly accurate. I'm going to draw in these medians. And when you do so, they should all intersect at the same point. So, now, it's called the center of gravity because it's basically a balancing point for that figure.
That's tricky.
So, I'm going to pass this around. Please do not stab this with your pencil like my last class did. That's why I had to just draw a new one. So, again, all I want you to do, again, is take your pen or pencil, whatever it is. Your eraser is going to work the easiest. Oops. Eraser is going to work the easiest, and you can balance it. If you want to try something else, you can use the tip of your pencil if you want to, or the tip of your pen. It's going to be harder to do, but again, please don't stab it like my last class did, because I'd like to use it for my next period as well. Now here's a paper clip. Not perfectly accurate, so it's a little off, but okay, so it balances. Again, the weight's distributed evenly throughout the triangle at that point. So, pass that around. Now, the other, don't stab it. I'm just saying. The other thing that we had talked about here, the centroid is 2/3 the distance from the vertex to the opposite midpoint along a median. So, what I'd like you to label on this triangle, and if you have enough room there, if you don't have enough room, you might want to draw it again somewhere else. You have plenty of room on the back. But let's say I used this line segment here. If I call this piece X, then this top piece would be 2X. It'd be twice as long, because this point here is 2/3, shh, ladies, again, it's 2/3 the overall distance from the vertex to the midpoint. And again, I could do that with each one of these. So like if I call this one Y, then this would be 2Y. If I call this one Z, then this would be 2Z. In each case, that distance from the vertex to the centroid will be double the distance from the centroid to the midpoint. Because again, it's 2/3 the overall length. All right. All right, circumcenter. For the circumcenter, draw a triangle. I would highly recommend, again, for these next two, some type of acute triangle. Does not have to be perfectly equilateral. Just needs to be acute. All right. For this one, again, drawing in all three perpendicular bisectors, I highly recommend trying to get as close as you can to the middle. I'd say roughly here on this one. You do not need to extend them all the way through the triangle. So I'm going to just draw it part way for the first one. All right. And then for the next one, again, I'm going to do the same thing that I did on the other one. I'm going to try and find where the middle is of this one. Since I'm trying to draw perpendicular lines, I rotate my paper again so that I can go vertical to try to find how to draw it perpendicularly. So now those two are intersecting there. If I do the third one accurately, they should intersect at that same point. So on here, again, I know that these two are equal. I know that these two are equal. And I know that these two are equal because they were perpendicular bisectors. Now, since we have any point on a perpendicular bisector is equal distant to the endpoints of the segment. So any point on this one is equal distant to these two endpoints, which are now vertices of a triangle. Any point along this one is equal distance to the endpoints of that segment. Therefore, it's equal distance to these two vertices. Any segment along this one is equal distance to its two endpoints, or these two vertices. So where the intersection is occurring means that this point is equal distant to all three vertices. Yes? So orthocenter, we have, let's see how these are perpendicular, because these are altitudes. The median is not perpendicular. It could be, but it doesn't have to be because it's going to the midpoint of the opposite side. Now, there will be triangles like an equilateral triangle where all the points end up in the exact same location. But for what we're doing on here, again, the median is going to midpoint. Altitude has to be perpendicular. So it's not going to be at the same place. So now, this point again is going to be equal distance to all three vertices. So we can say that the circumcenter is equal distant to all three vertices. So the circumcenter is equidistant to all three vertices. If you just want to write equidistant or equidistant, that's fine.
Equidistant?
Yes, it's a word.
That's a new word, Mr. Ward.
I actually think I've used it in a couple other definitions this year. But
I do not recall.
I could be mistaken. If I haven't used it, then maybe it is a new word to you.
Yeah.
But equidistant means equal distant.
Oh.
That makes sense.
Yeah. It's like an abbreviation at the beginning of the word distant. Yeah. All right. Now, since that point is equidistant to all three of those vertices, that means that we could actually draw a circle where this would be the center and the circle would go through all three vertices. What we call that is a circle that circumscribes the triangle. So, when we're right here is circumcenter is the center of a circle that circumscribes the triangle.
Too many words. There's a lot of things involving the word circle, and this is weird about triangle.
Triangles are magical. What can I say?
Yeah, triangles apparently just equals 180. 180 divided by 3 equals.
All right. Now, you can freehand your circle around this. Again, if you're looking at this diagram, what you should keep in mind is that the distance from each one of these vertices to that center would be like a radius for the circle that we're about ready to draw. So they would be all the same length. If you don't want to draw these radii in, you don't have to. If your image is getting a little crowded, that's fine. Leave them out. Again, we had that idea written down here.
What is that? Where's those pink lines?
Those are going to be the radii for our circle. Now, we're going to use compasses later in the year. I'm going to use a compass just to try to get this as close to accurate as possible.
That is a lot easier to use.
So,
Hey, that's one of the monkeys grow. Sketchy devil. Can I use that real quick?
you're going to break it again.
I'm not gonna. Sorry, joking. It's already broken, so you can't break it.
All right. Again, we'll go over using those later in the year. I was just trying to show that it's, again, equal distance to all three vertices. Now,
Hold it down. Hold it down.
the next one. Yes. So, the next one, the in-center. So now, we're going to draw a triangle, and I'm going to space it out so it takes the majority of this page. I'm going to actually go all the way out to the corners here, just to try to make it a little bit easier.
This feels like a threatening triangle. It's almost like it does what it was made to do.
Okay, that's fine.
All right. Now, thank you. My God, I made it through the whole class without anybody stabbing it.
Change that.
All right. So, on this last one, we're drawing in all of our angle bisectors. So again, try to get as close as you can to being accurate with your angle bisectors. You don't have to go all the way through, because on here they should intersect somewhere inside triangle. Now, I tried to make this an equilateral triangle to make it a little bit easier to bisect all the sides. And of course, it's not perfect, so.
Human error.
But again, they should roughly meet at the same point. And that point is our in-center. The incenter is now equidistant to all three sides. So it's the exact opposite of circumcenter. The circumcenter was equidistant to the vertices. The incenter is equidistant to the sides. And then the incenter is the center of a circle that is inscribed into a triangle.
That creator or creator?
Is that incenter is the center of?
Incenter is the center of a circle that is inscribed into a triangle. I know, it's awesome, isn't it?
It was better than you was.
It's like chicken scratch. But I'd write in cursive, but people can't read cursive, so unfortunately. My cursive is much nicer than my print.
I can read cursive because my mom writes me cursive, so if I can't read it, I'm
Alright. Now, as far as labeling special things on this triangle. So, again, the inside is equidistant to the side. Now, when we say it's equidistant to the sides, what's the shortest distance from any point to a side? Well, it's going to be the perpendicular distance to the side. So if I drew a perpendicular line in to any one of these sides, they should all roughly be congruent and represent the radii of the inscribed circle. Now, my compass isn't small enough to draw this, so I just have to freehand this one. So it looks something like that. Alright, and that's it for today. There's not an assignment today, but again, you have a quiz tomorrow, so make sure you study for your quiz.
Hey, do you know that show's made it for the championship? Yeah. It's because there's no competition. Last year we should have went there. No, because there's no. Okay, but we had a harder competition. All the games were like
I ain't touch it.
who were they tonight? They're playing good games.
Take the homework.
We were like a good goal. We were like a good. We were the Turkish team, but we were up there. And the legendary team. They're all on those teams. Which question did you go up? And they were the worst team in the conference. But they were so wrong. They had a 1 year, they had 1 year, and they had 32 points against them. He was wrong, but I
give it to Alex.
I should have started over there. Because like Xavier, he has no idea. He doesn't know.
Teamwork.
He was by play.
Pass the phone. You trust way too much for that. You trust us way too much for that. I mean, you guys can't really go far. I mean, you're not wrong. Like, we're even gonna run out of this room. I can just run the ball and then I'll go. You're not wrong. Like, literally. Like, it's not like I don't. That doesn't look safe. Yeah. Please, what? Alright, pass it. Can I get something? Yes. It's not like I know all your names. Or what are you gonna do? Please, Mom. You're not wrong. I can suddenly take I know all your names. Or you know my names. I know. What? Yeah. What? Ow! I have to run to the 300 building.
Take the big toe off and come back.
Yeah. Well, leave the middle one. How much time do you think you need to go back to? 10 minutes? I'm going to write this for 10 minutes. Alright?
Why does it smell in here? It smells like, I don't know. Can I go to the bathroom real quick?
And then just leave the cap right on the desk. Make sure it's safe. It's pretty cool.
Where did Jaylene go? Ryan, don't curse. Watch your language. Slap me. Slap me. I dare you. I dare you. Slap me right now.
You really slap a person in uniform. She will. He will.
No problem. Hey, don't curse.
I want to go home. I was just marching and my feet hurt. They're gone. What?
Water?
It's not bad. I just hate marching. No, I don't need water. Thank you. It's just my feet hurt and it's hot outside and I'm marching and they're made us like do things like 6 minutes as we're marching and I hate it. It's not hard. It's just that so many people are out of me like but what? No, commands to my platoon. So that was pretty cool. I'm waiting for Jaylene because she's like never here. I did it to everyone.
But taking a piss.
Probably been great.
Oh, yes, probably. I was going to say something, but I really wish exactly right there.
What's up with Christina? I was not the one texting you. That was Sarah from my phone. Yeah, I just hope you know that. I wish it wasn't. Where, April, where is Jaylene? Probably the back there. She's an old lady. She's pee all the time. But out. Oh, look, I got these back there. Oh, thanks. Oh, it smells like rice sweat.
I didn't tell you, bro.
Yeah, I got it. Ew.
That's fair. That's funny.
What? What? Hair?
When I got home, bro, my mom was on my ass. Oh, good. You don't know how to show up at your house?
Yes, I did. You can ask Evie. I did.
Bro,
Even
my
though
mom,
I went to
my mom
that.
texted me.
Did I ask out for it?
Wait,
She did. I did. No, Cassie. She did. And Cassie. Yeah, at the same time, I was like, Frank, and he was paying attention, then we told him, so now you guys,
I'm getting in more trouble than I was before. It's alright though, because I stole 2 pennies from my last game. I stole 2 pennies from my last game.
what does that have to do with anything? What does that have to do with anything?
Yes.
Yeah, that's what I thought.
Hey, Brian. Another name for ice cream.
It is not that.
Dude, the seltzer is served wide.
Blood drive shirt.
Oh my god, there's only one side.
Brian, can you come sit over here?
No, because if I get up,
That's still